Howdy, my name is Michael Balderas from Chem 119, and today we're going to be talking about extensive properties versus intensive properties, and a little bit of solubility in one of our demonstrations. So, what are extensive properties? Extensive properties are properties that depend on the amount of substance present. This includes things such as mass, volume, length, and moles, to name a few. Intensive properties, on the other hand, are properties that don't depend on the amount of substance present. This includes things such as density, temperature, boiling point, melting point, and the color. So let's check out a few examples. As we mentioned, extensive properties depend on the amount of a substance present. So the way we're going to show this is we're going to weigh out ordinary table salt into this container that weighs approximately 15 grams. So first we're going to pour a little bit of salt. So, with a little bit of salt that we poured out, approximately 4 grams of salt are there. So what happens if we add more salt? So to no one's surprise, we now have 9 grams of salt, meaning that the amount of salt in the container depends, or the mass of the salt in the container depends on the amount of salt that we poured out. Therefore, it is an extensive property. Intensive properties, on the other hand, don't depend on the amount of substance present. And in order to show this, we're going to use the salt that we used in our previous demonstration. So, we're going to place the salt in the water and stir. So this is where solubility comes into play. We know that NaCl, or table salt, is an ionic compound. And for one, ionic compounds are typically soluble. Furthermore, we know that sodium is a group 1 element, meaning that it has no exceptions and is always soluble. The reason this is because the intermolecular forces, or the positive 1 charge and negative 1 charge that sodium and chlorine respectively have, isn't very strong, so it is easily broken apart by water once it is placed inside, which is why we get no precipitate when we're done stirring. So, after doing the math, we found that the density of both beakers was 1.03 grams per milliliter. And the reason we only have 3 significant figures is because our scale was only able to read 3 and we were only able to read 3 from our beaker. So even though the second beaker had 100 milliliters less or so than the bigger beaker, they had the same density, which is why density is an intensive property. So hopefully those 2 examples helped you understand intensive versus extensive properties a bit better. Thanks and gig 'em.